or actually, or the symbol of your alphabet is not A, then this delta, the transition will just give you the null set. You know, in other words, just nothing comes out. Okay, all right. Now the second very simple type of regular expression is just, I've been calling it eta, but it's epsilon, eta, I think it's pronounced. Is epsilon, the empty string, right? So what's its language? The language of this regular expression. You know, what language does this regular expression describe? Well, it's just this one. It's just one member, the empty string. Okay. All right. So what NFA would recognize this language? Well, here it is. Pretty simple. It's probably even simpler than the first one. Yeah, I can put the textbook back. Now, why does that work intuitively? You know, it's so you've just got one state now, just one node, and the starting state is also the accept state, right? Because it's just one node. So it's obviously a starting state with a starting arrow, and it's obviously an accept state because of the two circles. Now, why does that work? So there's there's the epsilon. Okay, that's your symbol in a sense going in. So nothing. So no symbol goes in, and so you don't transition, right? So you just stay where you are. So all right. So what's the formal definition then of this machine? So there's only one state. Call it Q1. Right? So that's the set of states. There's just one of them. So sigma wiggly brackets Q1. An alphabet, whatever. Delta. Well, it's here. We'll talk about it later. So start state. Well, there's only one Q1, and the set of accept states. Wiggly brackets. You know, there's only one accept state. So the set of Q1. Alright, now the transition function, delta, again, Sipser's just used these R&D, so I guess the other members, other symbols in your alphabet, B presumably B is not, well, it doesn't matter what it is actually, because you're not reading any symbols, right? This thing doesn't read any symbols. So whatever R and B are, now what's a little r now? It's not too clear. I mean, he doesn't say. He just writes it up. What would little r correspond to? A member of big R? Yeah. So so nothing comes out. So the null set. Right? Just so remember delta. Now we're talking about an NFA, right? An NFA. And what do NFAs give? They give you a set of next states. Okay. Well, there's no next state, so it'll be the null set. Okay. Hence this. All right. Now the third possible simplest regular expression is just simply the null set. So R is the null set. Now its language is the null set. Now why is that? That was a bit subtle from a previous board. And why does that make sense? So if your regular expression is the null set, the language. It's the language that it describes will be the null set. Does that seem intuitively obvious? I guess. Right. Yeah. Okay. So what's the corresponding NFA for for the the null set? Well, there's just nothing. Nothing comes out. Right? So you just got a starting state. It's not even a. There's no accept state. Right? So it's about as simple as you can get. Right? So just the starting state. We just call it Q. Right? With no accept states. There's just nothing. Okay, so the form. So that's your machine. Think about it. Increasingly, there's more thought required. Okay, what's the formal definition then of this NFA? Well, it's only one state, the start state. So Q, just call it Q. Some alphabet, whatever. Delta. Well, it'll be the same as for here. That seems fairly obvious, I guess, given there's just nothing coming out. Start state is Q, just this one, right? And the set of accept states, well, none. There aren't any. Right, so this had one accept state, so we call that set Q1. But this doesn't have anything, so it's just the null set, the empty set. Okay, so just what do you call this thing? The zero with a slash through it, right? Phi maybe. Okay, and now the transition function delta. Well, it's the same here. There's it doesn't transition to anything. Okay, so it's just the null set. So that's your delta. Now, the case 4, 5, and 6 is mentioned a bit before. Now, to actually construct these, we've done that before. And remember in the proofs of closure, we had 3 proofs of closure. So we actually constructed. Now we have machine. You need to think in terms of machines now. So think in terms of the NFA of this one, the NFA of that one, the automatons, not regular expressions. So the corresponding. Well, let's start with the languages, the regular expressions. Remember, regular expressions describes a language. So you have a language corresponding to that and a language corresponding to that. You have an NFA corresponding to that language. Okay, so think of R1 now as the NFA that corresponds to the language R1. Remember, it gets a bit confusing. These R's, you can think of them as a regular expression that describes a language, or in this context, think of them as NFAs that, what's the word? Not accept, recognize the language. Okay, so imagine we've found an NFA that recognizes that language. And we've got another NFA that recognizes that language. Well, in the completeness proofs, we showed how to form an NFA that would be the union of 2 NFAs. Right? We showed how to do that. And similarly with the concatenation operator, and similarly with the star. Okay? So we've already done that. We know how to construct NFAs from component NFAs, you like. When we union them. So we know how to do that and that and that. We've done that, right? So we can save ourselves work. We just refer back to those 3 proofs on closure. So we know how to do that. And that's just what I'm just saying here, right? Right. So I don't know if you can see it here, but so we've now. Now this if part of the proof, it's a proof by construction, right? We actually construct the NFA that recognizes any of these 6 parts, 6 types of regular expressions. Now we've done that, so we've finished the if part. Okay, the if part of theorem 1.54. Well, then we'll in the next session. We'll do We'll do 2 examples of you're given two examples. Given two regular expressions, and then we'll actually construct the corresponding NFAs. That the regular expression would describe a language, and the corresponding, the equivalent NFA would recognize that same language. So I'll just go straight on in the next session.